Guys, good evening everyone. Welcome to the session and welcome once again to the GATE and ESE 2024 fundamentals on the BYJU'S exam prep. All right, and this time, we've been taking some GATE and ESE fundamentals, not from the technical, but again from a crucial subject, that is engineering mathematics, because you all know it again carries a weightage. Just Saturday I have taken a session where we have already talked about the importance of mathematics, its weightage, how to approach this subject, what are the best books to conquer this subject, and etc, etc, etc. And today we shall move forward in learning some of the important concepts of this subject, starting up the concept from linear algebra. Just a moment. Right, guys. So very good evening. Quickly update all your friends that the session is live. Share the session to all your friends so that students can join and start learning mathematics, and especially an important area, that is the rank of a matrix. And not only rank, after rank we'll go through linear system of equation, covering both non-homogeneous linear system of equation and homogeneous system of equation. We'll be conquering both of them. Correct? Yes. Chalo, so I think it's good to go. Let us get started. All right. Very good evening. Good evening, Divyam. Good evening, Shiva. Okay, chalo. So let's get moving ahead. This is about me, as many of you must be knowing it. This is Rakesh. I've secured All India rank 9th in GATE, completed my Masters from Indian Institute of Science, Bangalore, and it's been more than 12 years I've been teaching for GATE, ESE and various technical based examination. A quick update before we get started actually. Yes, guys, tomorrow, 18th April, just tomorrow at 7:30 p.m, all your favorite Joshit sir, M.Tech from Roorkee and more than 4 years of experience, is going to conduct a free mega workshop that is going to be conducted on the BYJU'S exam prep app, where we'll talk about 5 crucial points for GATE 2024 preparation beginners. Yes, if you are one of them starting, the GATE preparation, okay, what are the 5 crucial points to take care, okay, for this particular GATE examination, right? Good evening, Sagnika. And also, guys, the coming Sunday, that is 23rd April at 12:30 p.m, I bring to you the yet another next important workshop, and where I'm going to talk about 6 prime factors for what? To secure rank under 100. To secure rank under 100 in the GATE examination. This is again on the BYJU'S exam prep app. You can just go to the app and register for free. All right. Chalo. Very good evening all. Chalo guys, let's get started now quickly. Okay, let us start with the concept of rank of the matrix. Okay. Okay, the rank of a matrix. Let's get a definition and then let's get started. Let's get started. Okay. 3 वाले क्वेश्चन लाते थे. नहीं, संजय सर का क्लास अभी कुछ टाइम पहले हुआ था, नंदिता, but again don't worry, Sanjay sir classes will again come up, don't worry Nandita. Okay, so as per the availability of faculty, we just keep bringing the classes. So rank of a matrix, now let us understand, okay, is the largest order of any non-vanishing minor of the matrix. Now non-vanishing se mera matlab hai non-zero. It is the largest order of any non-zero minor of the matrix. Non-zero minor of the matrix. The rank of a matrix is said to be R. Okay, commonly we represent the rank by the notation of RA, or simply known as the row A. RA, or simply known as the row A. I will explain you what it is. The rank of a matrix is said to be R if it has at least one non-zero minor of order R, but at the same time every minor of order higher than R vanishes away, is equal to 0. Now let's understand with an example. Okay. Consider this case. The question is, find the rank of the matrix. Find the rank of the matrix A given to you 1, 2, 3, 4, 5, 6, 7, 8, 9. The first step is, what is the size of this matrix? Okay, let us all focus on what is the size of this matrix. Okay, it's a 3 cross 3 matrix. Very clear. It is what? It is a 3 cross 3 matrix. This one is a 3 cross 3 matrix. Now, as I just told you, rank of a matrix is the largest order of any non-vanishing minor. Non-vanishing se mera matlab hai, let me write down here, largest order of non-zero minor of the matrix. Okay. Now, first of all, forget non-zero. Let's talk about the size of the minor. Now, since the given matrix is a 3 cross 3, first of all, what exactly do you mean by a minor? Recall. Okay, very fundamental, sir. Minor means it's a basic maths up to 10th class. What is the meaning of minor? Any determinant means always square hota hai. Any determinant which you can extract from the matrix, becomes the minor of the matrix. Now, because here you have a 3 cross 3 matrix, what is the maximum possible determinant? Take all the numbers and calculate the determinant. Take all the numbers, calculate the determinant, it becomes a minor. So what is the largest possible minor? Okay, it's a 3 cross 3 matrix. This one is a 3 cross 3 matrix. Okay, my question to you is, what is the largest possible minor? What is the largest possible minor? What is that largest possible minor here? What is that largest possible minor? Chalo dekh lete hain. So largest possible minor, take out all the numbers, it becomes a 3 cross 3 determinant. So the largest possible minor will be the determinant of these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is a 3 cross 3. So largest possible minor is also a 3 cross 3 minor. Now, whether it is 0 or non-zero. Next question. What is the rank? Rank is the largest order of any non-zero, non-vanishing minor of the matrix. So is this given matrix? Okay. Is this given matrix is this given minor, 0 or non-zero? Let's calculate this determinant. Na? Let's calculate this determinant. Okay, let's come here peacefully and let's start calculating. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's start calculating this determinant. What I'm going to get is this is 1, and then cross multiply 5, 9, 45 minus 8, 6 are 48. Then minus 2 of, okay, 4 9s are 36 minus 42, and plus the last term is going to be 3 and its corresponding minor 4 8s are 32 minus 35. Let us calculate this value. This becomes minus 3. Minus 6 into minus 2 plus 12, and this is again minus 9, and minus 3 minus 9 is going to cancel out with 12, and the answer should be 0. The answer should be 0. Okay. No, rank is 0 means null matrix only, Divyam. Okay, means null matrix only. So what is the answer? The determinant is 0. So I have only one 3 cross 3 minor, but its value is 0. I have only one 3 cross 3 minor, as I have mentioned here, because I have taken all the elements and nothing else is left. You cannot form any other 3 cross 3 minor. You only have one 3 cross 3 minor and its value is 0. And its value is 0. Very clear. If its value is 0, it cannot be the rank. Okay. Rank is equal to 3 if you have a 3 cross 3 non-zero minor. So there is only one 3 cross 3 minor whose value is 0. Okay. So rank cannot be 3. So very, very clearly, then we will run, this is just the beginning, okay, basic calculations, then we'll learn about important points and keynotes about this matrix. So rank is definitely not equal to 3. Rank is definitely not equal to the 3. So let's check the minor of next order, okay. So now let's check minor of 2 cross 2. Let's check the minor of 2 cross 2. Okay, let's check the minors of 2 cross 2. For your reference, let me write down this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the matrix that we are discussing. Guys, this is not the proper way of calculating the rank, but I'm just explaining you the fundamental keywords about the rank. Then I will come to the method. Okay, then there are several methods and tricks. We'll come to that. So have a look into this. Okay, this is the matrix given to us 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me take any 2 cross 2 minor, dear. क्या करूंगा? Let me take any 2 cross 2 minor. Suppose I take this 2 cross 2 minor. Okay, suppose I take this 2 cross 2 minor, right? Okay, what is this? Sorry. What is this? This becomes 1 and 2 and 4 and 5. What is its value? Okay, its value is 1 into 5 minus 2 4s are 8. Its value is minus 3, which is non-zero value. which is non-zero. So I have a 2 cross 2 minor whose value is non-zero. Okay, whose value is non-zero. And what I told you, rank of a matrix is the rank of a matrix is the largest order of any non-zero minor. So I have a 2 cross 2 minor which is non-zero. Okay, so rank will be 2, and that is what I told you. Rank is said to be 2. Now apply this definition on 2. Rank of a matrix is said to be 2 when it has at least one non-zero minor of order 2. I want at least one non-zero minor. I don't say all 2 cross 2 minors should be 0. I don't say that all 2 cross 2 minors should be 0. I only want one non-zero minor of second order for the rank to be equal to 2. Okay, and that I have already got this. Okay, that I have already got. Okay, so I have one 2 cross 2 minor of non-zero value, so I can clearly say that the rank of the matrix is confirmed to be 2. I need not check other values. I need not check other 2 cross 2 values. If I have at least one non-zero minor of order 2, my rank will be equal to 2. Again, I repeat, this is not the proper way of calculating rank. Let's just understand the language and then I will tell you the methods. Proper methods and shortcuts and tricks, everything I will add upon. Okay, so rank here is equal to 2. Acha. Now from the same matrix, can I also take 1 cross 1 minor? What is a 1 cross 1 minor? A single element. Can I take any 1 cross 1 minor? Ye lijiye. Okay, let me take up this 1 cross 1 minor. Okay, suppose this is the 1 cross 1 minor I take. Okay, this is the 1 cross 1 minor I take. Isko yahan pe highlight kar dete. This one I am talking about. What is that 1 cross 1 minor I have highlighted? Let's say it is 9. What is the determinant? It is simply 9. This is also non-zero. This is also non-zero. So can I say that rank of the matrix is also 1? Rank of the matrix is also 1. Can I say like that? Okay, definitely not, na? Can I say that rank of the matrix is equal to 1? No, rank is 2 only. Rank does not equal to 1 because, as I clearly told you, rank of a matrix is largest order of non-zero minor. So since you have already found that a second order minor is non-zero, why to check first order? Largest order we need, na? And that is why, to give you that clarity, I have added one more point here. Look into this. Rank is R if every minor of order higher than R is 0. So rank will be 1 if and only if. Rank will be 1 if every minor of order higher than 1 is 0. But you have a minor of order 2 which is higher than 1, which is non-zero. No, so rank cannot be 1. So the moral of the story is you have to stop at the largest non-zero minor. You have to stop at the largest non-zero minor. Okay? Bilkul Divyam. See, for rank of a matrix, that is why I have designed 2 classes. Saturday ko maine brief bhi kiya tha. Let me brief you today also. We have the 2 classes. Number 1 is rank. Today we will learn concepts and we are of course solving some questions today also, but they are fundamentals. Okay. And today I will teach you the different methods. Ye to method nahi hai na, ye to just basics hai. I will tell you different methods. I will tell you the shortcuts. Today I will tell you the briefing and the concepts and the shortcuts. Then there is one more class of rank tomorrow whose name itself is question practice. Where there we will focus only on questions. Okay. So tomorrow at the same time we will have only question practice. Okay. But based on the tricks, the methods we learn today. Okay. So easily don't worry about the numerical part also. We have one full blaster numerical class only tomorrow. Kal pura numerical karenge. Chaliye aage badhte. Okay. So very clear everybody that the rank of the matrix is equal to 2 and that is why no need to check. This is itself a rubbish calculation. No need to check whether rank is 1 or not. If rank is 2, we have to stop there. Right? ठीक है. चलिए अब आगे बढ़ते हैं. Okay. So rank of this particular matrix is 2. Now listen to me very clearly. I started with a square matrix. Okay. A 3 cross 3 square matrix. What is the largest possible minor? I told largest possible minor means take out all the numbers, calculate the determinant. This is the largest possible minor 3 cross 3. Then I started calculating its value. Okay. Its value came out to be 0. But suppose if it was non-zero. मानने में क्या बुराई है? Suppose that if it was non-zero. If this determinant itself was non-zero, what will be the conclusion? My conclusion will be that I have a 3 cross 3 minor whose value is non-zero. I have a 3 cross 3 minor whose value is non-zero, and hence the rank will be 3. Suppose ye the non-zero nahi hai, but suppose if it was a non-zero, then I will say that rank is equal to 3. Rank is equal to 3. Acha. So, yeah, that is the problem with the PPT. Okay, no problem. I think that is erased. But yeah, no problem. I just calculated the numbers. Now I will write down this again. It got erased for a moment. We calculated this as 45 minus 48. Just a moment, guys. Hai na? 36 minus 42 and plus 3. 32 minus 35. And this was minus 3. Then plus 12 minus 9 came out to be 0. And because it was 0, I told rank is not equal to 3. But what I'm trying to ask you right now, that if the determinant was non-zero, then I will say the rank is equal to 3. And because it is a 3 cross 3 matrix, the largest possible minor is 3. So what is the largest possible rank? That is 3. Largest possible minor is 3 cross 3. Okay, so I can say that whatever is the rank of the matrix, it can be maximum equal to 3 or less than 3. Can it be greater than 3? Everybody think, and if you think that it can be greater than 3, please let me know. But I can say that rank at any cost cannot be greater than 3. Because it's a 3 cross 3 matrix, rank is less than or equal to 3. Okay. Largest value of rank is 3. And if by chance I had a determinant whose value was non-zero, again I tell you non-zero, then the rank would be 3. So what is the conclusion? That if you have a square matrix, yes, square matrix a conclusion hai pehle, right? If you have a square matrix, let's go to an important point here. Yes, very, very important point, that if you have a square matrix of size n cross n, then the rank is less than equal to n. This is understood. I told you, na, like rank less than equal to 3. Okay. But abhi forget the second point. Forget the second point. Okay, come to this. If a square matrix is non-singular, what is the meaning of non-singular? Non-singular means having non-zero determinant. So as I explained you, if that matrix has non-zero determinant, then the rank will be 3, which is the maximum possible rank. Okay, now if a matrix attains the maximum possible rank, I told you the rank less than equal to 3, suppose it is 3, then the matrix is said to have full rank. What is the concept of full rank? Dhyan dena. What is the concept of full rank? If a matrix achieves the rank which is equal to the maximum possible rank, then the matrix is said to have full rank. And for a square matrix, whenever you have non-zero determinant, then you will get the full rank. Correct? I can say now, when you have non-zero determinant, then you will get the full rank. So very, very important point you can note down here, that if a square matrix is non-singular, that means having non-zero determinant, it will have the full rank. Acha, what is that full rank? I told you, na, for a square matrix, rank is less than equal to n. Maximum rank is n. So it will have full rank, matlab it will have rank equal to n. Whatever the value of n is. Previous question, n was equal to 3. Whatever the value of n may be. Whatever the value of n may be. ठीक है, एक example लेके बताऊं? Let me take one more example. Okay, let me take one more example here. Let me write down one example here. Everybody. Suppose this is a given matrix. Now, intentionally, I have taken an upper triangular matrix so that determinant calculation is quick. Okay, what is the rank of this matrix? 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 Okay, tell me, what is the rank of this matrix? Dear, tell me. Yes, now see the determinant of the value, the determinant of the matrix. Since it is the upper triangular matrix, nahi pata hai to add on kar lijiye. ठीक है, anytime, if I get time, I will take some determinant classes also for you, but you must be knowing the basic fundamental of determinant. नहीं पता है तो I will tell you that whenever you have a upper triangular or a lower triangular matrix, determinant is simply equal to product of the diagonal numbers. So it is equal to 1 is multiplied by -2 is multiplied by 5 which is minus 10, and that is not equal to 0. If that is not equal to 0, if the determinant is not equal to 0, then the matrix A will have full rank. Then the matrix A will have full rank. Okay, and what is that full rank? The full rank for a 3 cross 3 matrix is said to be 3. Is said to be 3. ठीक है. अच्छा, but typo error यार, sorry. इसको 5 कर देते हैं. इसको 6 ही रखना है. If you want this to be 6, so this will be 6 only. Typo error, that is, so it will be 6 and this will be minus 12. Got this everybody? ठीक है. ठीक है जी. So then this matrix has the full rank. That is the very important point I was trying to focus you, that okay, if there is a square matrix of size n cross n, then rank will be less than equal to n number 1 point. Okay. Okay. Then whenever a matrix attains the maximum possible rank, then it is said to have full rank. So when will a square matrix have full rank? Very important point I am telling you, dhyan rakhna, that if a square matrix is non-singular, that is having non-zero determinant, it will have full rank. It will have full rank. Okay. Okay. Guys, some new background I have used. Any issues if you face with the ink or writing, something is not visible? I think it is visible. I am also watching it parallelly, monitoring it parallelly. But in case if you feel that some ink is not working out for you, you are not clearly visible, you can just share your feedback. This is a new template I have tried today. Okay. Chalo, badhiya. Okay. So now let's come to what happens if there is a non-square matrix. So if there is a non-square matrix of size m cross n, say for example, if there is a non-square matrix of the size m cross n, say for example, yahan likh dete hain hum. Okay, let me write down one example here only. Suppose I write down 1, 2, 3, 4, 5, 6, 7, 8, which is a matrix of size 2 cross 4, non-square matrix, 2 cross 4 matrix. Okay. Now think and decide what can be the maximum possible rank. Don't tell me what is the rank. वो बाद में निकालते हैं. What is the maximum possible rank for this matrix? What is the maximum possible rank for this matrix? Think and decide. What is the maximum possible rank for this matrix? Right. Can you have a 4 cross 4? Can you have a 4 cross 4 minor? Matrix is, what is rank? Largest order of non-zero minor. Largest order of non-zero minor. Zero non-zero बाद में देखेंगे. What is the largest minor? What is the largest minor? Okay, can you take a 4 cross 4 minor? For 4 cross 4, you need 4 rows. Not possible. Can you take a 3 cross 3 minor? 3 rows and 3 columns. 3 columns are available, but do you have 3 rows? So it's not available. Not available. But can you take a 2 cross 2 minor? So my first point here is, what is the largest minor? The largest minor itself will be only 2 cross 2. Will be only 2 cross 2. Will be only 2 cross 2. So what about the rank? It will be less than equal to 2. I'm not calculating, forget, I'm least bothered. I'll calculate that also later on. But what I'm trying to tell you, that if there is a non-square matrix of size m cross n, rank depends on what? Rank depends on either number of rows or number of columns, whichever is lesser. Okay, if I give you a 4 cross 2, okay, if it was a 4 cross 2, chalo, let me write this somewhere. Suppose ye dekh lijiye. If it was something like this, think and decide now. 1, 2, 3, 4, 5, 6, 7, 8. Then also, okay, this is 4 cross 2. 4 rows and 2 columns. But then also, what is the largest possible minor? You cannot have 4 cross 4. You cannot have 3 cross 3. Eventually, you can only take a 2 cross 2 minor. Right? So, what is the largest minor? Again, 2 cross 2. Again, 2 cross 2. Okay. Here, because the minimum value is 2. So, if there is a matrix of size m cross n, whatever is the lower number, okay, rank will depend on that only. Rank of A will be less than equal to minimum of mn. Minimum of mn. Any confusion, please ask me. It is minimum of m or n. Any confusion, please ask me. Isko hata dete hain. Okay. So this is the important point about non-square matrix. Then we will go to questions of non-square matrix also. Don't worry. We'll take those questions also. Now, very important point, very important technique, which will help you solve many of the questions. Rank of a matrix. Very, 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 very important. Very, very important. Okay. Even many of the gate questions also you can solve quickly using this point, and we will take several problem practice, don't worry. Rank of a matrix is equal to number of linearly independent rows or number of linearly independent columns. It depends. You can find a dependency in rows or you can find a dependency in column. No worry. Okay. But the rank of a matrix is equal to number of linearly independent rows or linearly independent columns of the matrix. Clear? I'll explain you this. Okay, let's go through some more important points and then I will come to this. Okay, rank of identity matrix. What is the meaning of IN here? IN se mera matlab hai identity matrix. Why? Identity matrix, dear, identity matrix is a square matrix. Okay, having non-zero determinant. Having non-zero determinant. Suppose I take 3 cross 3 I matrix. Suppose I take 3 cross 3 I matrix, right? This is a 3 cross 3 I matrix. What is its determinant? Okay, 1 into 1 into 1, because again it is a diagonal matrix. I told you now, for any triangular matrix or diagonal matrix, determinant is product of diagonal values. Determinant is 1, not equal to 0. And whenever a square matrix has non-zero determinant, it will always have full rank. So full rank matlab rank 3 hoga yahan pe. Rank of this 3 cross 3 identity matrix will be 3. Similarly, rank of a n cross n identity matrix will be equal to n. Will be equal to n. Okay. Rank of a null matrix will always be 0, because null matrix is a matrix which always have all elements 0. And since all the elements are 0, whatever minor you calculate, whether 3 cross 3 minor, 2 cross 2, everything is filled with 0. So all values will be 0. So its rank will not even be equal to 1. Uska rank 1 bhi nahi hoga. Right, it's only 0. So rank of null matrix is 0, and vice versa is also true. If rank of a matrix is 0, then it is only and only null matrix. Okay, there is no other matrix whose rank can be 0. Okay, sure. Okay, rank of A and A transpose will be same, because basically you are doing what you're doing, minor calculation, that is determinant calculation, and that does not change with the transpose operation. So matrix A and A transpose will have the same rank. Okay, then there are some identities which, you know, will take some questions and take reference if required, but right now just keep noting the points. Rank of A into B is less than equal to minimum of rank A rank B. Rank of A plus B is always less than equal to rank A plus rank B. Rank of A minus B is greater than equal to rank A minus rank B. And rank of a diagonal matrix is equal to number of non-zero diagonal elements. ये भी Echelon method से मैं clear करूँगा. Right, I'll make this clear by Echelon method. Okay, why the rank of a diagonal matrix is equal to number of non-zero diagonal elements. I will going to show you this point once I take you the Echelon method. What is the Echelon method? We are going to start it soon. Don't worry. Okay. Okay. So we'll learn this. Yeah. I'll share you the PDF on the group. Don't worry. Okay. But first, let us talk about in detail this particular point. As I'm telling you, this is very important. Rank of a matrix is number of linearly independent rows or linearly independent columns. Chalo, आगे बढ़ते हैं. Okay. Find the rank of this matrix. Now I'll explain you that point with question. What is the rank of this matrix? Tell me. What is the rank of this matrix? What is the rank of this matrix? Now I will solve you by two different ways. I'll show you by two different ways. Okay, ध्यान देना. Method number one. What is the determinant of the matrix? Now, two rows are identical, and whenever for a matrix two rows are identical, its determinant is 0. Otherwise, आप निकाल लीजिए determinant. Take out your time and calculate the determinant, but that's going to be 0, right? Two rows are identical, so determinant has to be 0. And because there is a 0 determinant for a square matrix, its rank cannot be 3. So rank definitely cannot be 3. Now what I will do? First I am telling that rough method again. What I will do? Now I will take out any 2 cross 2 minor. Pull कर लेते हैं इसको, ठीक है? Now I will take out any 2 cross 2 minor. 1, 1, 1 minus 1. This is a 2 cross 2 minor. Right? And that is minus 1, which is equal to minus 2. Which is non-zero. So I have a 2 cross 2 minor which is non-zero, and you have even if 1 2 cross 2 minor of non-zero value, then the rank is 2. Clear everybody? Then the rank is 2. ये तो हमने निकाल लिया. The rank is equal to 2. Very, very clear to everybody, I think. Not necessary to check all 2 cross 2 minor, but even if 1 2 cross 2 minor is non-zero, rank will be 2. Rank will be 2. अब यहां पे ध्यान दीजिए आप, अब यहां पे ध्यान दीजिए, ठीक है. What is this? Okay, forget that. Now let's come to another method. Let us come to method number 2. Look into the connection of rows. Okay, so 2 rows are identical. I told you now which 2 rows? R1, R2, R3. I can say that the row number 3 is equal to the row number 1. चलिए फटाफट से देख लीजिए. The row number 3 is equal to row number 1. Yes or no? Quickly. The row number 3 is equal to row number 1. ठीक है. करेक्ट है कि नहीं? R3 is equal to R1. So out of the 3 rows, one row is dependent. R3 is dependent on R1. Dependent क्या? It is directly equal. It is directly equal. Clear? It is directly equal. That means I have one dependent row. I have what? I have one dependent row. So how many independent? How many independent? So out of the 3, one row is dependent, na? Rest 2 are independent. Rest 2 are independent. Okay. And rank is equal to number of? Rank is equal to number of independent rows. So rank of the matrix, just a second, there is some issue I think. So very clearly rank of the matrix is equal to 2. Fantastic. Rank is equal to number of independent, linearly independent rows or linearly independent columns. You can check on any one of them. Either check on rows, either check on columns. Perfect. Clear everybody? ठीक है. So Uzair, that's what, na? That is why we are coming to this dependency method, or I'll tell you next echelon method, Uzair. Because if 1 2 cross 2 minor was 0, then I cannot comment. I have to check other 2 cross 2 minor. Okay. If all of them are 0, then only we will say that rank is less than 2. Okay, so checking all of them becomes tedious. That is why we are shifting to another method. Like one method I have told you, which is on the dependency or independency of rows or column. Next I will tell you echelon method also. Right, Uzair? ठीक है, Uzair Siddiqui. चलो. Now, let me take one more example explaining you the same point. Let me take one more example explaining you the same point, and that is the same matrix we have discussed in the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, a 3 cross 3 matrix with which I started with the concept. This is the matrix we started with, and everybody recall, we have calculated the rank of this matrix. We have calculated that the rank of this matrix is already 2. Already calculated, na? Rank of this matrix is 2. You can just go back to the video and check. Already I have explained you that why the rank of this matrix is 2. And if this is clear to everybody, okay, let me show you some relations now. Let me show you some relations. Please add, everybody, please add first and third row. Please add first and third row. Add first and third row. See what is the result. Add first and third row. 1 plus 7, which is double of 4. Which is double of 4. 2 plus 8, add rows, matlab add all the corresponding elements. 2 plus 8 is 10, which is double of 5. Third पे आ जाएंगे. 3 plus 9 is 12, which is double of 6. So what is that you are getting? What is that you are getting? What is that we have got here? अगर आप ध्यान से देखोगे, what is that we have got is कि when you add the first and the third row, you are getting twice of the second row. You are getting twice of the second row. Matlab, what is the value of R2? R2 का value हुआ R1 plus R3 divided by 2. अच्छा, whatever its value may be, there is a dependency, or you can place a dependency like this also. इसको थोड़ा सा modify भी कर सकता है. You can place it like this also. So what is R3? It can be written as 2R2 minus R1. That also can be done. 2R2 minus R1. ठीक है गुरु? हाँ जी गुरु, कोई डाउट हो तो आप बोल दीजिए, बिल्कुल उसको भी एक्सप्लेन करेंगे. So dear, R3 is 2R2 minus R1. That means the third row is dependent on the first two rows. Okay, it is derived by combining first and second row. Third row is automatically derived. So I have what? मेरे पास क्या है? I have one dependency. I have one dependency, right? So two independent, one dependent हो गया, तो out of the three left are two. So I have two independent rows. Clear? I have what? I have two independent rows. I have two independent rows, and that means the rank of the matrix, as I clearly told you, is equal to number of linearly independent rows or columns of the matrix. So rank of the matrix is equal to 2. Number of linearly independent rows. I have two independent rows, so the rank of the matrix is equal to 2. ये हमने पूरा derive भी किया था. This is by the basic definition of rank, that rank is the largest order of non-zero minor. वहां से भी 2 आया, and if you look into this, rank is 2. If you look from here also, the rank is equal to 2. Okay, rank is equal to 2. चलिए बढ़िया, ठीक है. There is one more method. I will show you how the rank is equal to 2, so that we have collection of all the methods today. And let's move towards that, and that is the echelon form. Now come to the echelon form. Now let us come to the echelon form. Anyone, see Divyam, वो तो आप rearrange कर सकते हो ना. Any one dependent row, like R3 is 2R2 minus R1, yeah, R2 is R1 plus R3 by 2. Any one is, you can rearrange. Okay, that is irrelevant. Any one is dependent. Okay, rest twos are, any one is dependent, rest two are independent. कौन सा dependent है वो matter of thought है ना. You may think R2, I may think R3, उससे कोई फर्क नहीं पड़ता. ठीक है. Echelon form, the next proper method of calculating the rank of a matrix. A matrix of the order m cross n, generally described with respect to a non-square matrix, so that square पे तो applicable हो ही जाएगा. A matrix of order m cross n is said to be in row echelon form. Is said to be in row echelon form. Now, first of all, understand what is the echelon form. I am taking row echelon form. Rank बाद में बताऊंगा, but first I am explaining you what is the meaning of row echelon form. A matrix is said to be in row echelon form if zero rows, if any, they must be below the non-zero rows. I will simplify and tell you, don't worry. Okay. And second, the number of zeros before the first non-zero element in each row is less than the number of such zeros in the next non-zero row. Now let me simplify this language for you. Second point, please note down that the number of starting zeros, then I will explain you with example also. The number of starting zeros must be in increasing order. And what is the first point? Zero rows, if any. If there is a zero row, then they must be below the non-zero row. Okay. So इसका ये मतलब है zero row. I will call the zero row as ROZ. I will call the zero row as ROZ. Right. If there is any ROZ, that must be at last. That must be at last. If there is ROZ. If there is no ROZ, no problem. But if there is a ROZ, row of 0, it must be at the last. ROZ here stands for row of zeros. A row full of zeros is known as ROZ. A row full of zeros. Clear? Then first let me explain you echelon form. Then बाद में rank की बात करेंगे. Okay, let's take an example here. Everybody find the rank of the matrix. But I'm telling you, forget the rank. Forget the rank. First let us understand what is this. What is this echelon form? Okay, so उसके लिए क्या करेंगे dear? I'll define a quantity. Let m, I'll just use some number, some variable. Suppose m. Let m is equal to number of starting zeros in each row. Let m is equal to the number of starting zeros in each row. Okay. Now have a look into this. Okay. What is the value of m here? How many starting zeros? I'm not telling you the number of zeros in a row. The number of starting zeros. Be very specific. So how many zeros are there in the starting? Nothing. Right. How many zeros are here in the starting? 1. 1 hai na? This is 1 0. Okay. Then how many zeros are here in the starting? 2. How many zeros are here? 2. For this, m is equal to 2. Clear? For this, the m is equal to 2. So how many zeros are there? How many zeros are there in the starting I have written? Is this following an increasing order? Is this following an increasing order? Yes, definitely, sir. 0, 1, 2. It is strictly increasing. It is strictly increasing. Yes, this is clearly following an increasing order. This is clearly following an increasing order. This is clearly following an increasing order. So number of zeros are following increasing order. Number of zeros are following increasing order. The number of zeros are following increasing order. Clear, everybody? Number of zeros are clearly following an increasing order. Okay, clearly following an increasing order. Now let's read this once again. Let's read this once again. मैंने क्या बोला था? The number of starting zeros must be in increasing order, yes. And if there is a row of 0, if any, it must be at the last. Do I have any row of 0? No, there is no row of 0. अगर वो होता तो last में होना चाहिए, otherwise we will adjust it. So there is only one condition, number of starting zeros. It follows an increasing order. That means the given matrix is in row echelon form. Correct? The given matrix is in row echelon form. The given matrix is in row echelon form. Right? अब देखिए यहाँ पे. If a matrix is in row echelon form, then what is the conclusion? If a matrix is in row echelon form, then rank is equal to number of non-zero rows. Then what is the rank? Rank is equal to number of non-zero rows of the matrix. Then the rank is equal to number of non-zero rows if a matrix is in row echelon form. Right? Yes, definitely, Jasmine. Whatever concepts are being covered here, that is 100% for GATE. Don't worry, GATE or any exam, ESE as well. Okay, the rank is number of non-zero rows. So, sir, how many non-zero rows are here? This is non-zero. This is non-zero. This is also non-zero. Zero row means all elements must be 0. So, all the rows are non-zero. All the rows are non-zero, right? So, whenever the matrix is in row echelon form, rank is equal to number of non-zero rows. And how many are non-zero rows? So that is 3. How many are non-zero rows? That is equal to 3. How many are the non-zero rows? That is equal to 3. Okay. Now this was to make you explain row echelon form. This activity was to make you explain row echelon form. Okay. But can you comment on the rank directly? Can you comment on the rank directly? Dekho. Can you comment on the rank directly? Have a look into this section. Method number 2. This is to explain your row echelon form because several questions can be dealt by row echelon form जो determinant से difficult होगा. Okay, but here this is an upper triangular matrix. Here this is what? This is an upper triangular matrix, and we all know quickly what is the determinant of upper triangular matrix. It is the product of diagonal numbers. 1 into 4 into minus 2. So the determinant is non-zero. So the determinant is non-zero. Okay, and if a square matrix any time has non-zero determinant, it will have full rank. So I should have full rank. I should have full rank. So rank is equal to 3. I should have full rank. Rank is equal to 3. Full rank का मतलब 3 cross 3 का full rank means rank is equal to 3. Right, everybody? Right. So why all this? Why all this? To explain you row echelon form, because in some questions row echelon form ही helpful होगा. Don't worry, question by question we will bifurcate the methods also. Clear? So rank is equal to 3, that you are seeing from the determinant method also. Especially square matrix having non-zero determinant, it will have full rank. It will have the full rank condition. Now next example, dear. Next example. Find the rank of the matrix. Now again, I will follow the same variable m. I will follow the same variable m. I will follow the same variable m. Dhyan dena. Right. M is the number of starting zeros. How many starting zero here? Sir, 1 starting zero. Right. How many starting zero here? There are 2 starting zeros. There are 2 starting zeros. How many starting zeros here? All are zeros. So how many starting zero? 3 starting zero. How many starting zeros? 3 starting zeros. Clear? How many starting zero? 3 starting zero. Is it following an increasing pattern? 1 2 3. Yes sir, 100% it is increasing. साफ दिख रहा है. Is it following an increasing pattern? Yes, it is following an increasing pattern, right? So there are two conditions. Now, the number of starting zero must be in increasing order, and if there is a row of zero, yes, if there is a row of zero, it must be at the last. It must be at the last. तो ये भी लिख देते हैं. ROZ is at last. Previous question में there was no ROC. I told you that is conditional. If there is ROZ, it must be at last. It must not be here. It must not be in the first or second at least. If there is any ROZ, it must be at last. So both the conditions are satisfied. Both the conditions are satisfied. This matrix is in row echelon form. This matrix is in row echelon form. Okay. This matrix is in row echelon form. And because it is in row echelon form, what is going to be the rank? The rank should be number of non-zero rows. The rank should be number of non-zero rows, right sir? How many are non-zero rows? Non-zero row, non-zero. Zero row means all elements zero. So this is non-zero, perfect. This is non-zero, perfect. But ye ho gaya zero. Okay, so third row cannot be counted, but rest two are non-zero rows. Rest two are non-zero rows. Okay, so the rank is equal to 2. For this matrix, rank is equal to 2. Number of non-zero rows, which is equal to 2. Correct, everybody? Which is equal to 2, 2, 2. Done hai. I think all suited. The rank is equal to 2. The rank is equal to 2. Perfect. All right, let's move ahead to the next question then. Okay. So hope you are able to now adapt what row echelon method, row echelon form is. Once you are able to get that where matrix is in row echelon form, then the rank is very simple. Number of non-zero rows. Number of non-zero rows is equal to the rank. Next case. Okay. First, let us figure out that whether it is row echelon form or not. Okay. Starting zeros. How many starting zeros? Sir, one starting zero. How many starting zeros next? Two starting zeros. How many starting zeros in the next? Again, two starting zeros. Again, two starting zero. Does it follow increasing order? Is it in row echelon form? Guys, your opinion. Is it row echelon form? Tell me. If it is row echelon form, then you know what to do. Rank is equal to number of non-zero rows. So is it row echelon form? Come on, tell me quickly. Is it row echelon form? Is it row echelon form? Number of starting zero must be in increasing order. यही तो condition मैंने बोला था. Then we will see ROZ. If there is ROZ, it must be at the last. Two conditions I told you. So is it row echelon form? Come on, think and decide and tell me. Yes लगता है yes बोलो, no लगता है no बोलो. Doesn't matter. It is all about thinking at the beginning. It's not about right or wrong in the beginning. During the learning phase, it is all about at least trying up, at least thinking up. Okay. Right. Yes or no? Confusions? Yes भी आ रहा है, no भी आ रहा है. Guys, I told you it must follow an increasing order. Okay. 2 and 2, it is same. Strictly increasing होना चाहिए. It must not be same also. This is same. Okay. It should be strictly increasing like 1, 2, 3. It should not be same also. It should not be same. And because it is same, okay, this matrix is not in echelon form. It is not in echelon form. Okay. So you cannot say that rank is number of non-zero rows. Can you convert this into the echelon form? Can you convert this into the echelon form? ठीक है sir, बिल्कुल. Can you convert this into the echelon form? Okay, let me write down the matrix for you. क्या है matrix? 0, 5, 3, 0, 5, 3, 0, 0, 2, 0, 0, 6. And I told you this is not in echelon form. This is not in echelon form. I already proved it to you. Okay. What I will do now is, I will convert this into the echelon form. I will convert this into the echelon form. Okay. I will convert this into the echelon form. What I am going to do is take the R3, dear. Take the R3. Okay. 6 minus 3 twos are. 6 minus 3 twos will become 0, na? Okay. So minus 3R2. So whatever operation you apply, you can apply on the row. You cannot apply on a single element. Okay. I'm just going to apply the row transformation here, and I'm going to write down R3 is R3 minus 3R2. R3 is R3 minus 3R2, and doing this, the matrix A that you are going to get is 0, 5, 3, 0, 0, 2. Now look into the third row. 0 minus 3 into 0, 0. 0 minus 3 into 0, again 0. 6 minus 3 into 2, again 0. Again 0. Now, what is the value of m? First row m is equal to 1. Oh, sorry, it's not 0. First row m is equal to 1. First row m is equal to 1. 1 non-zero. Second row में 2 non-zero starting. Second 2 starting 0. Sorry, non-zero गलती से बोल दिया. 2 starting zeros. Third row 3 starting zeros. Third row में there are 3 starting zeros. M is equal to 1 and 2 and 3. What is M? 1 and 2 and 3. What is the value of M? That is 1 and 2 and 3, which is clearly increasing now. They are not same. They are not decreasing. It should be strictly increasing. Same bhi nahi hona chahiye. Yes, 1, 2, 3. It is strictly increasing. Okay, it is strictly increasing. And yes, if there is a ROZ, it is at the last. Yes, this matrix also has a ROZ which is at the last. So no problem. ROZ must be at the last. I have the ROZ at the last. So this is in the row echelon form. This matrix is in the row echelon form. And if it is in the row echelon form, rank is equal to number of non-zero rows. Rank is equal to what? Number of, short form में लिख देते हैं. Short form में लिख देते हैं. Non-zero rows, NZR. You can write down the full form. NZR is non-zero rows. Okay. And how many non-zero rows? 2. Because third one 0 hai. Okay. First is non-zero. Second is non-zero. 0 row means all elements 0. So only one 0 row. Rest 2 are non-zero. Rest 2 are non-zero. So rank is equal to 2. So it may be the case that given matrix is not in echelon form, but you can convert this into the echelon form. You can convert this into the echelon form. Okay. Now, beginning question again. Again, same beginning question, guys. The same beginning question. Okay. We know that rank of this matrix is equal to 2. Right. We know that rank of this matrix is equal to 2. कैसे कैसे निकाला है? We have done it by number 1 determinant method. Number 1 we have solved this by the determinant method. Number 2 we have solved this by the independent row method. Independent row वाला जो concept बताया उससे solve किया है. Okay, so there are 2 ways. I have already solved this problem. Let us apply the same problem again so that all the methods are mixed, linked, and you are able to understand. Okay. So the rank is 2 by the determinant method also and by the independent row method also. Okay. Independent row method. Okay. Let us now apply the echelon method. Let us now apply the echelon method here. Okay. So let me rewrite the matrix here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me write down the starting zeros. How many starting zeros? Sir, nil, nil, nil. There is no starting zero everywhere. How many are the starting zeros? 0, 0, 0. Right. So, does it follow increasing pattern? No, sir. They are same. So, given matrix is not the echelon form. Given matrix is not in the echelon form. Very clear. Given matrix is not in the echelon form. So I know determinant method, I know independent row method. Okay, I know independent row method, but can I solve the same problem using echelon form? Every method has its important. तो पहले learn कर लेते हैं. Then with different questions, I will tell you which method is more suitable where. Okay, so this is not in echelon form. Can I convert this? Can I convert this? So here there are no starting zeros. Let it be 0. Now let me add starting 0 here. If this is 0, let me add 1 starting 0 here. Increasing order means what? If there is 0, next at least 1 होना चाहिए. Next at least 1 होना चाहिए. So I need to make this 0. 1 starting 0 means I need to make this 0, and 4 minus 4 into 1 will be 0. 4 minus 4 into 1 will be 0. Right? R2 I will write it as R2 minus 4R1. Okay. And here also I will make it as 0. So R3 I will write this as R3 minus 7R1. क्योंकि नंबर ऑफ जीरोस अगर यहां पे है तो एटलीस्ट यहां पे भी 1 होना चाहिए, यहां पे एटलीस्ट 2 होना चाहिए, बट एटलीस्ट इसको बनाते हैं। लेट्स स्टार्ट विद द फर्स्ट एलिमेंट एक्चुअली। ओके, सो डूइंग दिस मच what is going to be my matrix? Doing this much, what is going to be my matrix? It is 1, 2, 3. Then R2 is R2 minus 4 bar 1. So 4 minus 4 into 1, 0. 5 minus 4 into 2, minus 3. 6 minus 4 into 3, minus 6. 6 minus 12, correct. Then R3 minus 7 R1. So 7 minus 7 into 1, 0. 8 minus 2 sevens are, so minus 6. 9 minus 2 into, sorry, 9 minus 7 into 3, 21. So minus 12. Okay. Now what is the story of M? Okay. I have zeros. Okay. Then I have one starting 0 and again I have one starting 0. Again I have same. Again I have same. I have one starting 0 in the second and third row. This is again same. Okay. So I need to increase. I need to increase the starting 0 in the third case. Yes, 0 hai, 1 hai. This must be 2 or 3. It must be greater than 1. Strictly increasing. So what I'm going to do now, I'm going to target this. इसको भी 0 convert करते हैं. At least this should also be 0. This is minus 6. ऊपर minus 3. Minus 6, multiply the top element, multiply the above element by 2. That will also become minus 6 and then subtract. You get 0. And then subtract, you get 0. So what is the next operation, dear? The next operation that I'm going to show you is, I'm going to write down R3 is equal to R3 minus 2R2. Okay, minus 2R2 into 2 kiya, so both will become minus 6 and then subtract. Okay, and then write down what is the matrix. I'll write down here only. 1, 2, 3. First row is not disturbed. Here second row is also not disturbed. 0, minus 3, minus 6. And then C. Okay, R3 minus 2R2. 0 minus 2 into 0. This is 0. Minus 6 minus 2 into minus 3. 0. Even this minus 12 minus 6 into minus 2. So this will also become minus 12. Minus 12 minus 12 subtract here, cancel. So this is also 0. And now calculate the number of starting zeros. Now calculate the number of starting zeros. Nil. Then 1. And then 3. Actually, let me write it on the next slide. Got this? Let me write this on the next case. Okay. Let me write down this matrix. The obtained final calculation that I have is 1, 2, 3, 0 minus 3 minus 6, 1, 2, 3, 0 minus 3 minus 6, and then I have straight away obtained 0, 0, 0, and I was writing the number of starting zeros, which is nil. Second row, the starting zeros is 1. Third row, my starting zeros are 3. This is 3. This is 1. Okay. Do they follow increasing order? 0, 1, directly 3, but it is still increasing. Na kitna bhi increase ho, but it is still increasing. So do they follow increasing order? Yes, they follow increasing order. And there is a ROZ which is at the last. Yes, if there is a row of 0, it must be at the last. So given matrix is in the echelon form, row echelon form. Okay. So what should be the rank? Its rank is equal to number of non-zero rows, number of NZRs. This is non-zero. This is also non-zero row. Third row is completely 0. So how many non-zero rows are there? 2. Rank of the matrix is 2. Sir, anything new? Anything new? Rank of the matrix, thoda history mein chale jaye hum. If I go back to the history, the rank is 2. The third method I have told you, the rank is 2 for the matrix by determinant method, by independent row method, by echelon method. By echelon method. एक ही मैट्रिक्स है, रैंक तो एक ही होगा, बट आई एम शोइंग यू द वैरायटी ऑफ मेथड्स. देन आई एम शोइंग यू द वैरायटी ऑफ मेथड. ऑल राइट एवरीबॉडी, लेट्स मूव टू द नेक्स्ट केस देन. ओके, लेट्स मूव टू द नेक्स्ट केस. नाउ डिटरमाइन द रैंक ऑफ दिस मैट्रिक्स. नाउ समथिंग न्यू आई वांट टू कंसीडर हियर. Something new I want to consider here. Calculate the rank of this matrix. Now please see some connections here. Please see some important connections here. Right? देखो, 1 into 2 is 2. 2 into 2 is 4. 4 into 2 is 8. Very clearly that you multiply the row 1 by 2, you will get the row 2. You will get the row 2. ठीक है. Next आ जाते हैं. 1 into minus 5 is minus 5. 2 into minus 5 is minus 10. 4 into minus 5 is minus 20. very clearly, when you multiply the first row again by -5, you get the third row automatically. 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 R2 is 2R1, R3 is -5R1. Clear hai? R3 is -5R. So what do you get? What do you get? What have you got? You have got two dependent rows, na? R2 is also dependent, R3 is also dependent. Right? You have two dependent rows. Two dependent, not only one this time, you have two dependent rows, right? So that means only one independent rows. Only one independent row. And if there is only one independent row, the rank of the matrix is equal to number of linearly independent rows, which is equal to 1. So what is the rank of this matrix? The rank of this matrix is 1. Moral of the story is you have a row which is known as R1. You have a row which is known as R1. R2 and R3 are directly dependent only on R1. R2 is twice R1, R3 is -5R1. But some factor of R1. I can say that second row, third row, first row, they are all proportional. They are identical. They are proportional or they are identical to each other. Clear? They are proportional or they are identical to each other. Okay? All. Okay, R2 भी R1 पे depend कर रहा है, R3 भी R1 पे depend कर रहा है. So all rows are proportional to each other. R2 is twice R1, R3 is -5R1. So whenever all the rows are proportional or identical, same भी हो सकता है. Important point to note is, if all rows or even the same thing is applicable on columns, whatever I've taught you on rows, same thing can be applied to columns as well. Let us learn rows only. If all rows of a matrix are identical or proportional to each other, then its rank is always equal to 1. Then its rank is always equal to 1. Let me write down one more example here. Okay, suppose there was a matrix of this kind. There was a simple matrix of this kind. What is the rank of this matrix? What is the rank of this matrix? R3 is equal to R1. यहाँ पहले R2 से start करते हैं. What is R2? That is equal to R1. What is R3? That is also equal to R1. Okay. So everything is proportional. All of them are equal to R1. This is identical. All rows are identical. All rows are identical. Okay. Rank is equal to 1. Rank is equal to 1. Why? Because all rows here, they are not only proportional, they are identical. They are not only proportional, they are identical. They are identical. One more question, let me write down. Tell me. Now I'll show you two different corrections here. Okay. आप एक तरीके से लिख सकते हो, देखो 2 2s are 4, 6 2s are 12, 8 2s are 16. So R2 is twice of R1. R2 is twice of R1. Okay. Then 2 into 1.5 is 3. Forget the minus right now. 6 into 1.5 is 9. 8 into 1.5 is 12. Right. So R3 is 1.5 R1, but they are all negative. So minus 1.5 R1. All rows are proportional. Dear, this is the condition that all rows are proportional. Okay. Yeah, there is one more thing I can tell you. Okay. 2 3s are 6. 4 3s are 12. Minus 3 into 3 minus 9. So column number 2 is 3 times column number 1. Column में भी देख सकते हो. Column में भी देख सकते हो. Then 2 into 4, 8. 4 into 4, 16. 3 into 4, 12. So column number 3 is 4 times the column number 1. Okay. So all rows are proportional to each other. ठीक है, whenever all rows are proportional, rank is equal to 1. और you can again say ना, only one independent row, so rank is equal to 1. ठीक है, ये alternate method है. You just try to solve the question only on rows or only on columns. Mix मत करना. Okay, here all rows नहीं, here sorry, all columns. Here all columns. Here all columns are proportional. So the rank is equal to 1. So the rank is equal to 1. जैसे भी देख लो. Okay, all columns are proportional. C2 is thrice of C1, C3 is 4 times C1. Okay, rank is equal to 1. Okay, so some more points to be added so that, you know, many questions can be dealt quickly and quickly and quickly. Okay, quickly and quickly and quickly. So guys, password for today's PDF. Yes, today's PDF will be shared in my Telegram group and the password is going to be minor. Randomly I framed just now. I thought ki kya rakhe, so I have kept it as minor, M-I-N-O-R. The password for today's PDF, which will be in my Telegram group, is going to be minor, M-I-N-O-R, minor. I'll share you the link of Telegram also in case if you're not in my Telegram. Okay, the password will be MINOR. The PDF will be password protected. Only the students with the password who can join can open the PDF, and who have the password, anybody watching the session anytime, maybe now, maybe later, will get. ठीक है, अच्छा, एक और चीज मैं बता देता हूं आपको. One more important thing. One more important thing. Right. Tomorrow, at the same time, 9 p.m. Okay. Tomorrow, at the same time of 9 p.m. we have the questions practice on the same topic, rank. आज भी हमने questions किए, but few more questions, added questions, okay, with some little increased level. Okay, we'll do tomorrow. Tomorrow only question practice session. Okay, tomorrow only rapid fire question practice session on rank. Okay, same time 9 p.m. Okay, then next day same time 9 p.m. we have the linear system of equation, etc. We'll continue at 9 p.m. Right? We'll continue at 9 p.m. All right, guys. So starting from 2nd April, already started from 2nd April, learn with fun. Okay, where we are bringing you the gate concepts with some practical illustrations with their advantages, showing you practical experiments done so that to make your learning more and more fun. Subscribe to the channel so that you attend all these content, okay, without a miss. And for all those who have qualified the ESE prelims, we have the ESE mains course. Okay, which is offering you the comprehensive coverage for conventional practice. Yes, you have live conventional practice classes, conventional practice test evaluation, live doubt sessions, and etc. All of this already started from 3rd of April. And the GATE 2023, the BYJU'S exam prep success saga continues. So students outshine once again in the examination, right? 13 ranks under 10, 107 ranks under 100, 62 ranks under 50. Right, that's it, guys. Yeah, this is the link of my Telegram. You can join my Telegram using this link. Okay, for connection in the Telegram, or you know, you can connect with me on the Instagram as well. But my Telegram ID is this mentioned. You can type and search, or if you want, I'll share you in the Telegram as well. Just stay updated. Yes, guys. This is my Telegram. You can join this directly. I've shared in the comment box. See you tomorrow at 9 p.m. Bye bye. Thank you. Good night and stay safe and take care of yourself.